The reason that we have logarithms, well, multiple reasons, but one of the reasons is so that we can solve exponential equations. So we're going to start with, this is all going to be examples of all different kinds of strategies. This first example, e to an exponent equals e to an exponent. It should be fairly clear that these two need to equal each other. Negative x squared equals 5x plus 6. If I equal it to 0, x squared plus 5x plus 6, this factors. X plus 3, x plus 2, so I get two solutions. X equals negative 3 and negative 2. The next example, when I'm trying to get x by itself, I want to isolate the exponential part, so I'm going to divide by 4. So 3 to the x equals 64 divided by 4. 16. And then to get that x by itself, I'm going to change this to log form. Remember your snail. This is log base 3 of 16 equals x. And I can put this into my calculator. And I know that it is equal to 2.524. Rounded to 3 places. Okay, again, isolating the exponential part. Here's my exponential part I want to get by itself. First, I'm going to subtract the 5. Negative 3 e to the x equals negative 3. Divide by negative 3. E to the x equals 1. Solving for x, this time it's e. So I natural log the other side. So x equals the natural log of 1, which is 0. Again, isolating the exponential part. Here's your exponential part. So subtract the 4. 6 times 2 to the t plus 5 equals 7. Divide by 6. 2 to the t plus 5 equals 7/6. And now I'm going to go back to log form. I'm in exponential form. I'm going to snail my way around. Log base 2 of 7/6 equals t plus 5. So that means t is going to equal log base 2 of 7/6 minus 5. This is probably a more difficult one. It is one that is in a quadratic form. If you will, if we take e to the x and substitute that in with x, we can see that we'll have x squared minus 7x plus 12 equals 0. And I think this factors x minus 3, x minus 4 equals 0. So x equals 3 and 4. Put my substituting back in. This was e to the x equals 3 and 4. So if I write that twice, e to the x equals 3, e to the x equals 4. Get rid of an e by natural logging the other side. And we have two solutions, natural log of 3 and natural log of 4. And next example should be a simple one. Try it on your own. To get rid of a natural log, I'm going to e the other side. So x equals e to the 2/3, which equals, if I want to get it down to a decimal, 1.948. I could have also turned these into decimals, natural log 3, 1.099, natural log 4, 1.386. Okay, some one-to-one stuff. If I'm taking the log base 4 of something and equaling it to the log base 4 of something, these somethings have to be exactly the same. So it's just solving 3x plus 2 equals 6 minus x. Add my x, subtract my 2. Oops, that wasn't a 4, that was supposed to be an x. So I've got 4x equals 4, so x must be 1. On this next one, I'm going to use the same thing, but first I have to condense this into one log, so it'll be 1 to 1. Since it's subtraction, it's going to be changed into division. 5x plus 13 on top over 6, that was a base 3, equals log base 3, 3x. Now I'm just solving 5x plus 13 over 6 equals 3x. Multiply my 6 over. 5x plus 13 equals 18x. 13 equals, subtract your 5x, 13x. X equals 1. Okay, same with isolating your exponential. You want to isolate your natural log. Subtract 6. 3 ln x equals negative 2. Divide by 3. Natural log x equals negative 2/3. And to get rid of a natural log, I've got to e this side. X equals e to the negative 2/3. If I want decimal form, I can get it. Or if you leave it here, that's fine with me too. It's more exact if you leave it right there. There you go. Okay, this one, isolate my log. Get rid of that 3. Divide both sides by 3. Log base 4, 6x equals 3. And I'm going to have to snail this one. Change it into exponential form. 4 to the 3rd equals 6x. So x is going to equal whatever 4 cubed is divided by 6. 4 cubed is 64 divided by 6. Reduces to 32/3. Fractions always if you can. Okay, last two examples. I've got 2 logs, so I'm going to condense them into one. Since it's over addition, I'm going to condense them to multiplication. Log base 10 of x times x minus 9 equals 1. Then I'm going to snail. 10 to the 1 equals x squared minus 9x if I distribute. So if I set that equal to 0, x squared minus 9x minus 10. Hopefully that factors nicely. Negative 10, positive 1. So x equals 10 and negative 1. When you get to a problem like this last one, or you can check your work on the past ones that we've done, but this is an ugly one. You've got some logs, you've got some exponents. You really can't convert one to the other without it getting messy. If I snail it, if I make that an exponent and then I snail it around, I'm going to have 10 to the x squared minus 3 equals x squared. It's just not very pretty. So what I'm going to do is put this into the calculator. Okay, we're going to put one side of the equal sign on y1, the other on y2, and when they are equal to each other, like the problem says, we're looking for their intersection. So I'm going to go to graph. Blue one's the first one, or the left side, red one is the right side, and I'm looking for the x coordinate of this intersection right here, because we're trying to solve for x. So I'm going to go to second, trace. I'm looking for an intersection, so that's option 5. It's asking for, is this the first curve? Make sure you're on the right y1, and then you might have to arrow left and right to get your cursor on the graph. So I am on the blue line. I'm going to press enter. And it's going to ask me, is this the second curve? It's already on my line. So yes, I'm going to hit enter. You don't have to do anything but press enter on guess. And that's not my intersection. So let's figure out, it thinks it's down there. So maybe we need to use guess. Let's try this again. Second trace, intersect. Yeah, okay, there's my first line. That is my second line. And I'm guessing that they intersect right there. Okay, we do need to use guess. Okay, so my X solution is 1.884. Okay, what I forgot to mention in that video is that we know that a logarithm graph has a horizontal asymptote. So this graph actually continues down, and that other intersection it gave me was my other solution. So my X solutions are 0.032 and 1.884. I do need both of those. It did intersect twice. Even though on my graph, in my calculator, it doesn't show this line continuing on, but it does.